This video will look at how to manually download data from the AR1 and import that into Eagle.io. So this is a two-step process. It is also possible to download data direct from the instrument, such as if you're using an EXO-sonde, and also import that data into Eagle.io. So you may want to do these type of steps if you lose communications to an AR1 for a long period of time, and you need to your Eagle.io is your historian, and it doesn't have a full set of the data record. You can download the data after the communications have failed, and use that to keep Eagle.io updated. And similarly, if you had a fault with the AR1, but your sonde was recording data, you can download data from the sonde and send that to Eagle.io so that you've got a complete record. So the steps I'll show you here now are for downloading the data out of the AR1. I'm just going to give you a simple example. This is using devconfig for a USB connection again. The steps would be almost the same if you're using a connection over the cellular network, but in that case, it's probably just as easy to have the station send data to Eagle. So in this case, we are just using the USB connection to download data out of the AR1. So direct connection, select the right COM port and then hit the connect button. It will find the station. Now, the tab that we're using this time is the data collection tab. So this is this tab here. You may want to select your destination directory. For now, it's storing it to Campbell-SCIE devconfig. And the collection mode is up to you. Most recent interval is kind of the common one, but you may also select all data or a specific data range. I just know that, for instance, this has just been the last day that I've lost communication, so I'm going to actually just give you a basic example using the AR1 table only. So you then, once you've selected the interval, you select the tables that you want to download. Generally, it's AR1 and maybe water quality or sonde values, or DCS, depending on what sensors you've got fitted. But in this case, I'm just going to show you the AR1 table because I know that is on every station. But in general, you'd probably select two or more tables because you'd want the AR1 table plus the table of the sensor data. So then you click the start button, and that will tell you fairly shortly afterwards, depending on the date range, that it is complete. And so now we have the data stored on our computer. Now we can use that data to upload to Eagle.io. So now I'm going to show the Eagle.io side of importing data on a training station that I've set up. So the steps are quite straightforward. You find your AR1 in the workspace tree on the left. You use the pull down arrow to select historic data and then use the import option from that menu. So there's import and export, as well as the ability to view the data from charts and table view. In this case, we are selecting import, and it brings up a import wizard to bring in the data. So our file type is delimited text. It is possible to have JSON time series, but I know that from our Campbell data logger, the data was stored as comma separated values, which is using the comma as the delimiter. So then you select your file, browsing to the folder that we stored to in the previous part, and we select the latest data file. So I'm opening that file. Now the write mode, generally you leave it as merge and overwrite. There's no need to change that. And the time zone is also the time zone of your station. So given that the data logger hasn't changed, there's no need to change the time zone. Okay, so then we have the parser set up where we kind of tell the Eagle.io the format of the data being used. So going across the top, we know that we have commas separating our values. If it's not from the Campbell, if it's from an instrument, maybe that's a different delimiter. You need to know that for your instrument. We have our data in columns, not in rows. So 99% of the systems you'd come across will all be column-based data. Our labels are in this row here. We can see the battery voltage, internal temperature, internal humidity. So that's row 2. So we set the label row to row 2. We set the units row, which is the values, the units for those labels, is row 3. Now, when we have decimal values such as 13.13, the separator between the whole number and the decimal part is a period, so that's correct. We're not really dealing with text, so we can leave it as the qualifier for text is quotes, and that is the last that we need. Now, for this, we need to set up the timestamp of the record. So the time has actually been recognized, because if we look at the settings, we can see the time format is matched to the format that we're actually using here. So this is the default values. But if you use a different data source, such as the EXO Sond, which has a different format time, you will need to go through and modify the strings here that define the format of the numbers. So, for instance, 4 uppercase Y's in a row mean 4-digit year. The separator of a dash. 2 uppercase M's denotes the month in 2-digit format. 2 uppercase D's denotes the day in 2-digit formats. Now, it may be that you don't have the leading 0, in which case you would just need 1 digits rather than 2 digits. So 2 means it looks for the leading 0. If you just had 1, it would not have the leading 0. And then you have 2 digits for the hour, 2 digits for the minutes, and 2 digits for the seconds. So that is correct. We can leave that as is. And so then we have all the other columns defined. And then we move on to the next screen, and we look at which records we actually want to import. So we don't need the first column, which is a record value. Now we do want battery voltage, but instead of creating a new parameter called battery voltage, we actually have an existing one that is called AR1 battery voltage. And then we do want internal temperature, but we actually have an existing one that has internal temperature. So you would go through all of these parameters and you would look at them to find the existing value that you need to match up, current average, current maximum. And you can see when doing this that there is actually a lot of diagnostic information stored with each interval of the AR1 table, because this diagnostic information can be used to go back and see where something's changed. And you might wonder, for instance, serial number. Why would I want to look at the serial number? If the serial number changes in the data record, then that will tell you that the hardware has changed on site. So all of these have been selected to be stored because it does tell you that if you can go back through the historic record and see if something has actually changed. So we've considered each of these parameters that we're storing and believe that it's useful for you. So you don't have to import them all, of course. This is optional, but yeah, I would recommend that you keep them all, because you never know. It's Murphy's law that once you deselect a value, that's the time you're actually going to need it. So I'm getting close to done here. I've still got a few more parameters to match up. Cell signal strength is obviously a good one. Now, we actually don't have cell net band in our data in our previous parameters, so we can ignore that one and continue on with the other values. So latitude and longitude is obviously straight from the GPS, really useful to know when your site's moving. GPS satellites in view is useful to know how many, we don't have that one, how many satellites we use to calculate the latitude and longitude. So now we've allocated all our points, we click the next button, and it processes the import and updates all the value to the latest information. So that's a really simple way of merging the data from your telemetry source through to the AR1 for manual data downloads. And even, of course, if there's a problem with your AR1, using data direct from the sonde to import into Eagle.io to make sure that you don't miss out on any data in your historian. All right, thank you very much.